Hello, I'm Philip Stoughton. I'm here on the Scoop Studio at Productronica 2017, and I'm joined by Nick Dage from Dage. Great to see you, Nick. Some exciting new developments in the X-ray field. Tell me what you've got on the booth.
Well, it's been an exciting, couple of years in Dage. We released Prod17 and Prod17 18 months or so ago now, and they've been really well received. It's an exciting new platform for us. So now we have Prod5 and 7 out. Our focus really is on the software. We've just released a new image filter, which uses high dynamic range technology to really get the best out of the images that you see using X-ray. So a lot of the problems that our customers have seen in the past is when you've got a sample that's maybe got some very thin areas that create a very bright X-ray image, but then you'll have some big heat sinks or some big heavy components, especially in power PCB type applications. And those you then have very dark areas, very bright areas, and it's kind of hard for conventional X-ray images to deal with both. So we have some new technology, not dissimilar to the types of techniques that are used in camera phones these days to get the best out of dark and bright images, that takes a lot of different composite images, puts them into one, so that you can get some beautiful results showing very nice contrast in both dark and bright areas, all in one image, so you don't have to have a high power and a low power image side by side to really see what's going on in your sample. So it's quite an exciting new feature that's rolling out at the moment, and everybody we show it to, it's one of those nice features where you show it to people and they just, their eyes light up as they see the improvements. So
it's kind of a eureka moment, I guess. And does that process take longer, or does that impact on the efficiency of the equipment?
It's a one-shot process. So you press a button, wait a few seconds while it takes a few different composite images, and then you're ready to go. It puts the final image on the screen. And you go from having something that's maybe showing a good representation of the image, but there'll be naturally light and dark areas, to it's kind of a false image, because it's areas that appear dark may be it's kind of hard to explain, but it's more about an illustrative image rather than a true X-ray image where you're actually looking at bright and dark. But
yeah, so you've got different densities there as a result of that. So when you look at that, what are people using that data for? They're obviously using it to recognize good and bad product, but also process improvement. How do they use that, and how does your software help them with that?
It's all about, it's two things really. It's operator time saving. So if you've got an operator looking at one composite image, that's a lot quicker for them to do than to set the X-ray power up high and then back it down low, depending on which part of the sample they're looking at. And so with operator time saving comes, cost saving, better utilization of the tool. It's also great for archiving as well. So instead of saving two images that show the best of both parts of your board, you're just saving one image to come back to later on. So although data storage is very cheap, it's much easier to find one image than it is to go and find a pair of them. So
yeah, and you've also got to wade through them, and you've got to work out which one you need to look at. So there's a great deal of value there. Any particular industry that was demanding this technology? What was it that led you to develop it?
There were an awful lot of samples where fundamentally electronics in general. So anytime where you've got things like big heat sinks on top of a board, or maybe you're looking at a board within some sort of metal enclosure where you're getting thick bits of metal getting in the way of your image and masking some areas and not others. So very good for power electronics. We're seeing a lot of interest in these sort of applications with automotive and the sort of high power demands that these are putting on circuitry components these days. But conventional PCB manufacture benefits as well too.
Yeah, it makes perfect sense. Nick, thanks for stopping by. Thanks for telling us about that, and enjoy the rest of the show. Thank you.
Thank you very much.
Thanks.